Good morning, students. Today I am going to discuss about what is electrolyte, how the ionization is affected by dilution, and the different acid-base theories. First of all, what is electrolyte? The substance which ionizes in aqueous solution is called as electrolytes. We discussed this topic in a brief in 10th class also, like sodium chloride. Sodium chloride ionizes as Na positive, Cl negative, HCl, H3O positive and Cl negative, sulfuric acid, hydronium ions and sulfate negative, sodium hydroxide and etc. In 10th class we also studied in another way also, that ions are responsible for the conduction of electricity, correct? When we add sodium chloride in water, it conducts electricity, but if we add glucose in water, the conduction is not possible because no ionization of glucose is taking place. Well, ions are responsible for conductor of electricity. Greater the concentration of ions, higher will be the conduction of electricity. Now, presently in some cases, irreversible sign is used, in some cases reversible sign is used. Irreversible, it means there is complete ionization. When strong electrolyte ionizes almost completely in aqueous solution. If 1 mole of sodium chloride is taken in a 1 liter, it may be possible 0.98 mole, 0.96 or 0.97 mole will change into Na positive, Cl negative. That I use the word almost completely. Same is the case with HCl and sulfuric acid and sodium. But in this case, the ionization is very less, and we call it as weak electrolyte. Weak electrolyte ionizes very less. If we take up 1 mole, it may be 0.01 mole, 0.2 mole, 0.02 mole will ionize in aqueous solution. So if I take up 1 mole sodium, 1 mole HCl dissolved in 1 liter solution and 1 mole acetic acid 1 liter solution, the more conduction is taking place in case of HCl and less in case of acetic acid because ionization is less. Less ions are formed. Reversible sign is there. We can also express in another way on the basis of degree of ionization or degree of dissociation. What does it mean? It is the ratio of number of moles of electrolyte dissociated to the total number of electrolyte present in the solution. Now in this case, if I take up 1 mole and 0.98 mole or 0.97 moles are ionized, and as such alpha is approximately 1. This is alpha, number of moles ionized by 1. On the other hand, in case of weak electrolyte, 0.08, sometimes even less than this one. And in this case, the alpha is very, very less than 1. If alpha is very, very less than 1, in that case, 1 minus alpha is taken as approximately 1. So 1 minus 0.08 comes to 0.9 to very close to 1. And 1 plus 0.08, 1.08, that is also equal to 1. So 1 minus alpha in calculation, 1 minus alpha is also taken as 1. 1 plus alpha is also taken as 1 because alpha is very, very less than 1 in case of weak electrolyte. You have to remember in plus 1 and plus 2 both classes also. So in case of strong electrolyte, ionization is complete, but in case of weak electrolyte, ionization is very less. Now, what is the effect if if the dilution is carried out. Dilution is carried out by adding more and more solvent. More and more solvent. So for this I take up a weak electrolyte, a very simple electrolyte to understand the concept. AB changes A positive, B negative, initial constant C00. Here alpha is the degree of annihilation. The concentration becomes C alpha because alpha goes to this side on this into 1 minus alpha. कैसे? Suppose अगर यहाँ पे 1 मोल होता, अल्फा उधर चला गया तो क्या हो जाता? अल्फा ई ना, the concentration is C times, तो यहाँ पे क्या आ जाएगा? C. Now by law of chemical equilibrium, K is the equilibrium constant. Product concentration over reactant concentration. Concentration A positive is C alpha. Concentration of B negative is also C alpha. And in this case, C into 1 minus alpha. One of the C is cancelled out. C alpha is 1 minus alpha. And we know that for a weak electrolyte, 1 minus alpha is approximately taken as 1. So this relation becomes C alpha square. Or alpha is equal to K by C under root. What is C? C is the concentration, number of moles per liter, and by V. On dilution, M will not change. It may be electrolyte or non-electrolyte. Suppose this is a beaker and 1 mole, any electrolyte is taken up. Suppose STK is taken and 500 milliliter water is, and we get this solution of concentration C. Now for dilution, again I will add 500 milliliter solution. तो dilution हो गया, क्या acetic acid की quantity कम होगी? On dilution, there is no change in amount of acetic acid. The concentration changes. First is 1 by 500 now, or per liter 1 by 2. Now 1 by 1. लीटर में कहेंगे तो 500 लीटर पर लीटर लेना है ना, तो पर लीटर 500 मिले तो हाफ लीटर। या आप ये कर लीजिए, यहाँ पे पहले 1 लीटर लिया और आप 1 लीटर पानी और डाल दिया। तो पहले क्या कर रहे थे 1 by 1, अब क्या हो गया 1 by 2। एसिटिक एसिड चेंज, तो N चेंज नहीं होगा, डाइल्यूशन पे क्या चेंज होगा V। तो जितना V क्या चेंज हुआ, V इंक्रीज हुआ। तो जो डाइल्यूट करेंगे V increases and hence the alpha increases. Alpha is directly proportional to square root of a volume, और इनवर्सली कंसंट्रेशन कम हुआ, वॉल्यूम इंक्रीज हुआ, जो डाइल्यूट का कंसंट्रेशन कम हुआ। तो on dilution, the degree of annihilation, degree of dissociation increases. Means more and more ions are formed in case of weak electrolyte on dilution. You have to keep in mind this concept. Now, let us take up various acid-base theories. Initially, different theories were proposed. They are only have the practical background, which turns blue litmus red, which neutralizes base. They are soapy to touch. Sorry, acid turns blue litmus red, neutralizes base, corrosive property, and base, red litmus blue, soapy to touch, neutralizes acid, etc. etc. But they are all experimental. Bitter in taste, acid or sour in taste, etc. They are already concept, but no practical concept was provided. If there some formula is given to you, how do you judge that if this is an acid or a base? And first attempt to study the acid and base and to provide the acid and base theory was by Arrhenius. According to Arrhenius, acid give proton in aqueous solution, while base give hydroxide ions in aqueous solution. And the strength of acid or base depends on the concentration H positive or H negative or dissociation constant. अगर H पॉजिटिव कंसंट्रेशन ज्यादा होगी, जब एसिड डिसोसिएशन कांस्टेंट ज्यादा होगा तो स्ट्रॉन्ग एसिड. अगर OH नेगेटिव कंसंट्रेशन ज्यादा होगी, जब बेस डिसोसिएशन कांस्टेंट ज्यादा होगा तो स्ट्रॉन्ग बेस. In addition, it is H positive from acid and OH negative from base participate in neutralization. First theory and so many concepts was provided by Arrhenius. Like HCl, according to Arrhenius, it should be H positive aqueous, Cl negative. Since it provides H positive, hence it should be an acid. Irreversible sign, strong acid. Irreversible sign, strong acid. In this case, it gives OH negative, strong base. Irreversible sign, strong base. See, acidancy. Acidancy ammonium hydroxide. It gives OH negative, but here is reversible sign. It is a weak base. Acetic acid, reversible sign, but it gives H positive, it is a weak acid. This is a weak acid. The K is very high, or Ka, K is acid dissociation constant, and Kb is base dissociation constant. Means H positive into OH negative upon HCl, Na positive OH negative upon NaOH, NH4 positive OH negative upon NH4OH. In this case, the concentration is less. Weak electrolyte, Kb is less. Now, is stated that it is H positive from acid, OH negative from base participate neutralization reaction. NaOH dissociates Na positive, OH negative. HCl, H positive and Cl negative. NaOH plus HCl gives NaCl in water, and we know that NaCl in aqueous solution gives Na positive, so this reaction is in water. Now, before reaction, Na positive is there, after reaction Na positive is there, means there is no change. Before reaction is Cl negative and after reaction is Cl negative, which will undergo a chemical change. That is OH negative and H positive, they form unionized water. This is what he stated. The property of a base is not due to Na positive. Na positive is sodium chloride may be. The property of acid is not due to Cl negative, it is H positive. H positive from acid, OH negative from base participate in neutralization reaction. This was the first theory, and so many concepts were provided by the Arrhenius. This was a systematic theoretical concept. He discussed in detail relative acidic and basic strength, neutralization reaction, etc. At the same time, it has lot of limitation. And first limitation is, according to Arrhenius theory, acid gave H positive in aqueous solution, but H positive does not exist in aqueous solution. This is a serious limitation. H positive doesn't exist in aqueous solution. It always exists in the form of hydronium ions. Means H3O positive, H5O2 positive, and so on. H positive cannot exist in aqueous solution alone. H positive plus water gives H3O positive. If there are two water attached to one H positive, then it is there H5. And these are called as hydronium ions. In aqueous solution, we get hydronium ions, not H positive. Another limitation is there are a large number of compounds which don't have H atom, We cannot explain on the basis of arranged that they are acid, sulfur dioxide, carbon dioxide, sulfur trioxide, nitrogen oxide, boron trioxide, they are well known acids. But we cannot explain on the basis of Arrhenius theory. So there are large number of substances which don't have OH group, but well known base, calcium oxide, ammonia, sodium carbonate, sodium hydrogen carbonate. We cannot explain. And there are large number of compounds which contain OH group but cannot act as a base. Acetic acid that contains OH group but cannot act as a base. So it needs modification. The next theory was provided by Lowry and Bronsted. According to Lowry and Bronsted, proton donor is an acid and proton acceptor is a base. Any substance can act as a acid or base that depends on the nature of another. Which one has the urge to accept proton, which one has the urge to lose proton. HCl plus water. Here HCl, here HCl changes to Cl negative, means it loses proton, and proton loser is an acid, but water accepts proton and hence the base. Similarly, acetic acid loses proton, but water accepts proton. On the other hand, here water loses proton. If water loses proton, the proton donor is acid, while ammonia accepts proton. Therefore, it is a base. Similarly, here ammonia accepts proton, base. HCl loses proton, is. Here carbonate accepts proton, base, and water loses proton, base. Sometime water acts as a base, sometime water acts as an acid. That is depends on the relative strength. Which one has the greater tendency to lose proton and which one has the greater tendency to accept proton. In the same way, if hydronium ion to change into water, it has to lose proton, and proton donor is an acid. Therefore, this is a conjugate acid. In Cl negative changes to HCl, it has to accept proton. Therefore, it is a conjugate. Corresponding to acid, conjugate base. Base corresponding conjugate acid. Acid conjugate base. Base conjugate acid. Similarly, base conjugate acid. Acid conjugate base, and so on. But sometimes in the examination, the questions are asked write down the conjugate acid and base of the following species or molecules or ions or anything. Like what? Conjugate acid. Conjugate acid लिखना है तो ये क्या हुआ? बेस. और बेस क्या करता है? प्रोटॉन एक्सेप्ट करता है. तो इसके अंदर क्या का प्रोटॉन एक्सेप्टर, तो मुझे H पॉजिटिव ऐड करना होगा. If I would like to write to conjugate base, then it is an acid. Acid donates proton. So we have to one hydrogen, H3O, neutral, 0, and this is plus 1. 0 plus 1 plus 1. So this becomes H3O positive. There is neutral, and out of neutral, you have to remove plus 1 charge. So this comes out to be 1 negative. 1 hydrogen less हुआ, charge neutral में से plus 1 minus करना है. तो क्या हुआ? minus 1 charge. For further classification, if you would like to write down OH negative. Conjugate acid, you have to add H positive, and you have to subtract H positive. So minus 1 plus 1. Add over neutral. A minus 1 already is there, and you have to remove plus 1 further. So this comes out to be -2. O2 negative. Hydrogen subtract कर दिया, only oxygen, we left with only oxygen and charge is 2 negative. Conjugate acid at H positive -2 and +1 -1, but you cannot remove H. There is no H, but conjugate base is not possible. Possible ही नहीं है. Acetic acid, conjugate acid, you cannot add here H because carbon is tetravalent and 3 and 1 covalence is satisfied. But the oxygen has the capability to accept proton, and hence you can write here H2 positive. And this is conjugate acid and conjugate base. एसिड क्या करेगा? प्रोटॉन लूज करेगा. कहां से करेगा? यहां से करेगा. Ester support, being a strong acid give proton, not accept proton. This is very strong acid, and hence is not. This is weak acid, hence it accepts proton. But this is not strong. This is a weak acid. This is strong. Strong acid is not capable to accept proton. Hence, this process is not used. And conjugate base, you have to subtract this one. And so many questions are available in your book. You have to write down the conjugate acid and base, in which case the possibility is there, in which case the possibility is not there. And such type of questions are asked. And last theory is Lewis theory. Sorry, in this case, first, we left with one point. Are arenous acids are also lower in prospect acids? Now we are in a position to explain the why NH3 is a base, why CO329 is a base. We cannot explain on the basis because they don't have OH group. Still, we have the limitation. The substances which don't have H atom cannot donate proton. Hence, we cannot explain the escape behavior of these substances on the basis of Lowry-Bronsted theory also. इस थ्योरी के बेस पे भी हम उन एसिड के बारे में नहीं बता पाएंगे जिनके पास H नहीं है. जिनके पास OH नहीं है, बेस है, वो तो हम एक्सप्लेन कर पाएंगे, लेकिन वो नहीं बता. तो वो किसके बेस पे एक्सप्लेन करेंगे? लिविस थ्योरी के बेस पे. जो प्रोटॉन H पॉजिटिव H नेगेटिव के बारे में बात ही नहीं करता. ये किसके बारे में बात करता है? Electron pair. Electron pair donor is a base and electron pair acceptor is acid. Means electron rich species are base and electron deficient species are acids. So according to this theory, कौन-कौन Lewis acid हो सकते हैं? All cations except group 1 and 2 metal ion. Aluminum ion acts as a acid. Copper ion 2 positive, silver, manganese, ammonia, nickel, and they can act as acid, but not as copper, calcium, because calcium belongs to group 2. Not potassium or sodium or magnesium. Potassium belongs to group 1, magnesium group 1. But H positive is there. Another, the molecule in the central atom has incomplete octet. Beryllium chloride. The valence shell of beryllium contains 2 electrons and shares 2 electrons with chlorine. Total 4. Octet is incomplete. Means electron deficient. This acts as a Lewis acid. Boron trichloride. Valence shell contains 3 electrons. Shares 3 electrons with chlorine. 6 electron deficiency. Similar to aluminum ferric chloride, they are electron deficient species. Molecule contains central atom of different electronegativity attached to multiple bond. Atom of different electronegativity attached to multiple bond. Like carbon dioxide. Carbon dioxide contains C double bond O, aromatic sulfur dioxide, oxides of nitrogen. That's a lyricist. So metal or compound which can provide vacant orbital, nickel 3D8, it can provide vacant orbital. Manganese, iron, they can provide vacant orbital. They also act as a Lewis acids. The Lewis base, all anions, Cl negative, Br negative, OH negative, Cl negative, NO2 negative, SO4 negative, all anions are base. Means they are capable to donate electron pair. Or molecule in the center atom contain unshared electron pair. Ammonia. The valence shell of nitrogen contains 5 electrons, 3 are used, contains 1 lone pair, hence is capable to donate lone pair. Water, alcohol, they contain lone pair. Amines, they act as Lewis base. So electron pair donor is a base and electron pair acceptor is an acid. Like boron trifluoride has the deficiency of electron, since it is electron deficient, it is Lewis acid, while ammonia contains unshared electron pair. As a result, this electron pair can be one-sidedly shared with this one and form coordinate bond, and we will get here N, B, H, 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 F, F, F. This donates lone pair. Therefore, this is a base, and this electron accepts lone pair. This is acid. Similarly, carbon dioxide. HO negative. So this electron pair can be donated to this one. When O double bond C O, when it donates electron pair, it forms a bond. The valence of carbon is completed 1, 2, 3, 4. So this electron pair is shifts to this position. You get this one. जिसको हमने क्या लिख देंगे HCO3 नेगेटिव. यहाँ पे ऑक्टेट कंप्लीट है या वैलेंसी कंप्लीट है. अब अगर मैं यहाँ पे डबल बॉन्ड लगा देता हूँ तो वैलेंसी 5 हो जाएगा. कार्बन की 5 वैलेंसी नहीं हो सकती. जब इसने इसके साथ इलेक्ट्रॉन दे दिया तो 1, 2, 3, तो ये बॉन्ड कैसे बना था? एक इलेक्ट्रॉन इसका, एक इलेक्ट्रॉन इसका, ये इलेक्ट्रॉन इस ऑक्सीजन को मिल जाएगा क्योंकि ऑक्सीजन को इलेक्ट्रॉन मिल गया. दिस कैरीज नेगेटिव चार्ज. दिस वन. तो ये इस थ्योरी के बेस पे हम बहुत सारे केसेस कर सकते हैं. ये थ्योरी बहुत ही सिंपल है. जब सभी हमारे अर्हेनियस थ्योरी फेल हो जाए, लोरे-ब्रोंस्टेड थ्योरी फेल हो जाए, उस केस में हम इस थ्योरी को अप्लाई करते हैं, लिविस थ्योरी को एट लास्ट। दिस थ्योरी इज वेरी सिंपल टू अप्लाई, at the same time it has some limitation. According to this theory, acid donate lone pair and base a separate lone pair, but there are large number of reactions in which there is no electron pair donation accepting is taking place, like NOH plus HCl, NOH plus H2SO4, there is no donation acceptance of electron is taking place. We cannot explain on the basis of this one. And this theory is so simple that every reaction appears to be acid-base reaction, though they are not acid-base reactions. So if acid donates electron pair, base accepts lone pair, in that case there must be a coordinate bond formation. And the reaction should be slow or moderate. But majority of the reactions are fast reaction. We cannot explain on the basis of this theory. So next time I will take up the dissociation constant and the pH value, and for this you must go through the log table, how to calculate, use the calculations with the help of log table. तो आपको लॉग टेबल की अच्छी मास्टरी होनी चाहिए, नहीं परचेज किया तो परचेज कर लेंगे लॉग टेबल को, वहाँ पे कैलकुलेशन देखेंगे कैसे करते हैं।